Hello and welcome to this video on multiplication and division facts. This is part of the Functional Skills Maths Level 1 and Level 2 course. The learning outcome for this video is to use multiplication facts and make connections with division facts. Our linked learning refers back to this relationship that we saw at the beginning of the calculations video, where addition and subtraction were opposites and multiplication and division were opposites. And really what this video does is it concentrates on multiplication and division as a method for doing various calculations. So using multiplication facts could allow you to do calculations by connecting something you know about a multiplication to find out something that you don't know. So for example, if you were struggling to remember what 8 times 7 is, then you could break it down into smaller pieces. So if I know that 4 times 7 is 28, then 8 times 7 is 2 lots of 28. So add them together to get your 56. This is very similar to the chunking that we used as one of our processes for doing multiplication. We can use this process on bigger numbers. So for example, what is 15 times 8? Well, if you don't want to use the column method, we can use the chunking where we know that 10 times 8 is 80. Therefore, 5 times 8 must be 40. All we need to do then to work out 15 times 8 is add the 80 and the 40 together to give us 120. So, using multiplication facts, work out the correct answers for these calculations, circling your correct answer. Again, if you need more time, just pause the video. Did you get the correct answers for these? If you didn't, then try and get some more practice on either the chunking method, which is really what this video is about, or using the column method or the grid method. It really doesn't matter in the exam which method you use. One of the multiplication facts we've already come across is to multiply numbers by 10, 100 or 1,000. Now, if we take a number like 32, we have 3 tens and 2 ones. So to multiply it by 10, what we're essentially doing is moving it one place to the left with respect to the place values. So the 3 would go into the hundreds, the 2 would go into the tens, and a 0 would become a placeholder. So this 0 here becomes our placeholder. We do the same again when we multiply by 100. So we move it to the left, but this time with 2 placeholders for the 2 zeros on the 100. And then finally, to multiply this number by 1,000, we move it along to the left again, and then the 3 zeros for the 1,000 become the placeholders. So we've multiplied it by 10, 100 and 1,000. So 32 times 10 is 320, and so on. Some people like to look at it in a different way, where you've got 32 and multiplying by 10, you just stick the 0 at the end. Same again for multiplying by 100, and same again for multiplying by 1,000. But visually, this is what you're doing. You're moving it 1, 2 or 3 places to the left Here are some numbers for you to have a go at. Don't forget to pause the video if you'd like to give yourself a little bit more time. Now let's reveal the answers. Hopefully you got all of these correct. 17 times 10 is 170, times 100 is 1,700, and times 1,000 is 17,000, and so on for the other numbers. So a nice straightforward multiplication fact for you to remember. What we can also do when we multiply by tens, hundreds and thousands is we can actually do the basics with the basic numbers and then either add or take away the zeros depending on whether we're multiplying or dividing. So on this example here, I've got 80 times 200 and it looks like a big complicated problem, but it isn't if you break it down into its parts. 8 times 2 is 16 and we ignored 3 zeros, just like we do when we use the grid method. So I can put the 3 zeros in after I've done the basic two numbers. Have a go at these below, where we want you to multiply 40 and 900 by 30 and 600. Okay, let's look at this. So 40 times 30 becomes 4 times 3, which is 12. I ignored 2 zeros, so I put the 2 zeros on. So that's 1200. 40 times 600, well, we do the basic numbers first. So 6 fours are 24, and then we have 3 zeros that we ignored. So 40 times 600 is 24,000. The next one, 900 times 30. Well, we ignore the zeros, we just do 9 times 3, which is 27, and there are 3 zeros that we ignored. And then the final one, we've got 900 times 600. Well, we know 9 times 6 is 54, and then we've got 1, 2, 3, 4 zeros. So that's 540,000. Now let's do the same with division. So if you're dividing by 10, 100 and 1,000, we're going to move the number 1, 2 or 3 places to the right with respect to place values. So let's start with our original number of 280,000. So 280,000. So we have 4 zeros on our original. Now, when we divide by 10, we're moving the numbers one place to the right. So it becomes 28,000. We do the same again when we're dividing by 100. So the original number would move 2 places to the right. And then finally, dividing by 1,000, we would move it another place to the right. So it becomes 280. So dividing by 10, it becomes 28,000. Dividing by 100, it becomes 2,800. And dividing by 1,000, it becomes 280. Now, if we're going to divide by 10, 100 and 1,000, the quick way people might think of it is dividing by 10, we knock off one of the zeros, so it becomes 28,000. Dividing by 100, we knock off 2 zeros, so it becomes 2,800. And finally, dividing by 1,000, it becomes 280. Have a go yourself and divide these 4 numbers by 10, 100 and 1,000. Now let's reveal the answers. I've speeded up the video just to show you how you can do these questions quickly. Hopefully you got them all right. Let's look at dividing other numbers by tens, hundreds and thousands. So Just like when we multiplied numbers by tens, hundreds and thousands, we do the numbers first, but this time we cancel the zeros out. Let me show you with this example. I have 800 divided by 20. So I can do the 8 divided by 2, which I know is 4. But this time, instead of adding the zeros that we've missed out, we need to cancel one of these zeros with one of these, leaving just the 1 0 that we put on our answer. Have a go at the questions below and see how you get on. So for the first one, we have 12,000 and we're going to divide it by 20. So we can divide 12 by 2, which is 6. We've got a 0 here that we cancel out there, which leaves 2 zeros we need to stick on our answer. For 12,000 divided by 400, we divide 12 by 4, which is 3. We cancel 2 zeros off there, leaving just 1 0 we put on our answer. For the other number that we've got 360,000 and we're going to divide it by 20. So 36 divided by 2 is 18. We've got a 0 here that we cancel out, so we've got 1, 2, 3 zeros left. So the answer is 18,000. Next, we have 360,000 divided by 400. So 36 divided by 4 is 9. We've got 2 zeros on the 400 that we cancel over here, so our answer has the 2 remaining zeros added on. So our answer is 900. Now let's look at an exam-style question using these skills. John walks 5 kilometers from his house into town. If there are 1,000 meters to 1 kilometer, how many meters did he walk? So we need to start by taking the 5 kilometers and then multiplying it by 1,000 because there are 1,000 meters to a kilometer. So 5 times 1,000 gives us 5,000 meters. Now let's look at some multiplication and division relationships. Now we should be aware that if 7 times 2 equals 14, then 2 times 7 is equal to 14. Therefore, if we move this around and we say 14 divided by 2, we must know it's 7 because of that inverse relationship between multiplication and division. And also that if 14 is divided by 7, that also gives us 2. So there's a relationship between the 7, the 2 and the 14 depending on whether we're multiplying or dividing. And most important of all, this is one of the methods that we use for checking our calculations. It's called the reverse method. So if you have a calculation such as 7 times 2 equals 14, that would be your original calculation, and the inverse check or the reverse check would be 14, which was your answer as your first number, divided, which we swap our sign around, divided by 2 gives us 7, and that is a valid check for a calculation. Let's show you how this works on a simple calculation such as 5 times 8. It's asking us to do the calculation first and then check our calculation. So 5 times 8 I know is 40 from my times tables. Now this would be my original calculation. So in order to do my check, I would put my answer first. Because I'm reversing the calculation, I reverse the function that I'm carrying out, the 8 goes here and it's equal to 5. And this would be called our check. So that's our original calculation and our check of a calculation using what we call the reverse process. So this is how they could ask you a question in a functional skills exam. So how many 7 centimeter pieces of ribbon can you cut from a ribbon that is 35 centimeters long? So knowing what we do about the way they word the questions, it's asking us to divide 35 by 7. So if you know your times tables, you know that it's 5 times. So there's 5 pieces of ribbon. Now it's asking us to do a check of our calculation. So our original calculation was 35 divided by 7. So we call that the original calculation. Now let's do the check. Our answer is 5. Our function was divide, so we inverse the function, we change it to a multiply, and we have 7 here. And then our first number now becomes our answer. And this is what we call the check. So this is called a reverse calculation check. There are other questions they can ask you in the exam about this relationship between multiplication and division. What they can do is give you the answer to a complicated multiplication, like 32 times 16 equals 512. Now we know from our reverse calculation that if we do 512 divided by 32, it should give us our 16 back. So they've changed our calculation around. Now you'll notice on our original we had 512, but they're asking us for 5,120. So the size of the number being divided has increased by 10, therefore our answer will increase by a scale of 10. Have a go at this one and see if you can use that multiplication and division relationship to work out the answer. Don't forget to pause the video to give yourself more time. Okay, so let's start with what we know. So if we reverse this calculation and we say I've got 78 and I multiply it by 20, it gives me 1,560. So I know that I've got the 78 still, but my 20 has become 200. We've actually increased the size. So if the size of this number increases by another 10, then our answer needs to increase by another 10. So it becomes 15,600. Related to multiplication and division relationships are the reverse process, where they'll give you a problem with something missing within that problem. So when you look at 6 times something equals 24, from our reverse relationship, you should know 24 divided by 6 would give us that missing thing, which is 4. 6 times 4 is 24. Here, again, our reverse relationship would say 45 divided by something gives me 5, but also 45 divided by the 5 will give me this missing number, which is 9. Again, our reverse relationship takes into effect here on this next one. Something times 12 is 108. So 108 divided by 12 will give me that missing thing, which is 9. And then finally, I've got something divided by 11 is 11. So to get this missing number, 11 times 11 gives me 121. So 121 divided by 11 gives me 11. The challenge question at the bottom of the page uses the same process, where we've got 216 and we know if we divide it by 18 it gives us the missing number. So we've got a long division to do. We've got 216 divided by 18. We know 118 is 18, so we can put 18 there, and there's a remainder of 3. 18 goes into 36 twice. So 216 divided by 12 gives me the 18. Now that we have some of the basics sorted from what we've done within the lesson, we now need to look at how this could be adapted into problem solving. And problem solving is a big part of your exam. So what is problem solving? Well, problem solving is the process of finding solutions to problems, and we don't know how they're going to present these problems to you in the exam. So here's a basic example of how they could turn something very simple that we've done in today's lesson, like adding two numbers here, into a problem solving exercise. So problem solving isn't adding 247 to 476, it's filling in the blanks on this addition over here. So we know how to do the one on the left because we've done that in the lesson. 6 and 7 is 13, carry the 1. 7 and 4 is 11, plus the 1 we carried is 12. And then 4 plus 2 is 6, plus the 1 we carried is 7. So that is just a straightforward calculation that you'll probably get in the non-calculator exam. What you could get if they wanted to turn this problem into a problem-solving exercise to get you thinking outside the box, quite literally, is something like this. So 7 plus something equals 3. Well, it has to be a 6. So 7 plus 6 is 13. There's no other way of doing it. So I have to carry 1 here because 7 and 6 is 13. So I've got the one that I carried plus the 7. So 8 and something is going to give me 2. So the only number this could be is 4, because 8 and 4 is 12. So 8 and 4 is 12, so I put the 2 down, I carry the 1. 4 plus 2 is 6, plus the 1 I have missing is 7. So this is a problem-solving method of giving you something simple, where you have to think outside the box on how you get your answers. And what we'll try and do in every lesson and in your homework is give you some problem-solving exercises to help you get better at this thinking outside the box process. The only buzzword we need to remember on this particular video is reverse calculation. So if you're given a simple calculation in an exam, such as 7 times 4 equals 28, and that's your original calculation, then to do your reverse calculation, your answer becomes the first number. You reverse the function, divide it by 4, and your first number becomes your answer. And that is your check of your calculation, your reverse check. And that completes the learning outcome for this video, where we were using multiplication facts and making connections with division facts. If you'd like more practice on this topic, then please use Moodle, where there'll be homework, quizzes, and extra worksheets on this topic.